Algebra II Cram, New York State Algebra II Regents, Common Core, Key Facts, Trigonometry, Ambiguous Case. Question 8, the law of sines. A over the sine of A is equivalent to B over the sine of B is equivalent to C over the sine of C. Now, the odds of someone doing what you tell them to do is pretty slim to none, but I guarantee you that if you cram with me, you'll become an Algebra 2 master. So inbox me at memedicine@gmail.com to order this complete cram session, and definitely spread the word to your friends and classmates who also need to cram. Inquire about other subject areas available. All right, so let's delve into the question. Review question 8. Sam is designing a triangular piece for a metal sculpture. He tells Martha that two of the sides of the piece are 40 inches and 15 inches, and the angle opposite the 40-inch side measures 120 degrees. Martha decides to sketch the piece that Sam described. How many different triangles can she sketch that match Sam's description? Is it going to be 1, 1, 2, 2, or 3, 0 triangles possible? Definitely press pause and take this moment to put your answer solution together. All right, so hopefully by now you are able to arrive at a solution, and if not, that's completely fine. What we're going to do first, in order to arrive at the correct solution, is draw a rough diagram. And in drawing this diagram, I don't want you to worry about scale or accuracy, and the labeling of the vertices of the triangle formation is arbitrary, okay? So the system I'm going to use is the ABC system. So we have one point of our triangle, A, the second point, B, and the third angle, C, okay? All right, so now we have something that fits into our ABC triangle naming system, okay? And what I want you to realize that this is a classic case of the ambiguous case. If two sides are mentioned, so we have the 40-inch side as well as the 15-inch side, okay? And one non-included angle, the 120 degrees opposing the 40-inch side. Then what we're going to do is attempt to figure out how many angles can be formed. And it's important to know that if this information is given, two sides and one non-included angle, and when I say non-included, I mean that the angle isn't sandwiched between the known sides, then either 0, 1, or 2 triangles may be drawn to fit the given data. And in order to figure out whether it's 1, 2, or 0, we have to use the law of sines, okay? So to find the measure of angle B, that's what we're going to do next. Since we have side B, we're going to use the law of sines. The law of sines basically states that in a triangle, the sines of the angles, so the sine of A, is in proportion to the sides directly opposite them. So we see here that the sine of angle A, well, A over the sine of angle A is equivalent in the ratio is the same as the sine of B in the denominator, and side B in the numerator is equivalent to the ratio of side C divided by the sine of angle C, okay? All right, so the law of sines again can be used to find an angle if two sides and one non-included angle are known. And this is the scenario we're presented with here in this particular situation. So we know the measure. We're going to isolate the side B over sine of B is equivalent to C over the sine of angle C, okay? So we're just dealing with this here. We're not looking at A yet. So since we're given all the information for angle C and side C, we go ahead and we plug that in. So we can put 40 over the sine of 120 is going to be equivalent to 15 over the sine of B, because we don't know yet what our measurement for angle B is, okay? And then when we cross multiply, we get that 40 times the sine of B is equivalent to 15 times the sine of 120. Now, when we go ahead and divide both sides by 40 to isolate the sine of B by itself, we get this, that the sine of B is equivalent to 15 times the sine of 120. This should be 120. Hopefully you can see this. Over it. So yeah, this should be a 2. The sine of 120 over 40, okay? And when you go ahead and evaluate this expression, you get 0.3247595. And this sounds about right for a sine value. They usually fall between 1 and -1. And since the sine is positive, we also need to remember that the sine is positive in quadrant 1 as well as in quadrant 2, okay? And that means that two angles are possible based on this one sine value. So we're going to use the inverse sine feature in our calculator. And if you don't know how to pull up that feature, you can inbox me at memedicine@gmail.com and I'll direct you to the pricing and ordering instructions for my videos that show you how to do just that, okay? And you also want to make sure you're in degree mode so that you don't get an answer that's actually meant for a radians system, okay? All right, so yeah, you're going to use the inverse sine function in your calculator to find out the acute angle version of angle B, okay? So if the measure of angle B is acute, then the measure of angle B is equivalent to the inverse sine of 0.3247595. And when you go ahead and press the enter button on your calculator, you're going to get that the angle is equivalent to 18.95, okay? And the reason why I say that the angle is acute is because you have to recall the Cartesian coordinate system when you're first taught about the trigonometry concepts. Here you have a right triangle. You're usually taught based on a right triangle. And remember, what is the value of sine? It's going to be that the sine of theta, whatever this acute angle is equivalent to the y-coordinate divided by r, where r is usually called the hypotenuse, or the measurement of the ray that the terminal side of the angle makes with the Cartesian coordinate system. So the reason why you get this value automatically when you do inverse trigonometric functions in your calculator is because this angle is a reference angle, and reference angles are in standard position. And what I mean by that is that the vertex is at the origin and the initial side touches the x-axis and the terminal side is somewhere off in quadrant 1, okay? So take a moment, catch your breath, let your brain catch up. And I'm pretty sure some of you have this down pat already, but just for those of you who don't. So this angle, again, is our reference angle. Theta equals theta-ref. And every time you actually do a trigonometric function problem in your graphing calculator, they're giving you the angle. They're giving you the values based upon this type of reference angle. Like in order to get angle values in other quadrants, whether it's quadrant 2, 3, or 4, you would have to do some algebraic manipulation, which is not too difficult. It just involves either addition or subtraction, okay? So the reference angle, again, is the positive acute angle that theta makes with the x-axis. And remember that acute angles fall between 0 degrees and 90 degrees. And that's why our angle is an acute angle in quadrant 1, hence the value 18.95. It's greater than 0 degrees, yet less than 90 degrees, okay? But what we also have to do now is increase our awareness that there is another angle with a positive sign in quadrant 2, because you also have quadrant 2 being bound by the positive y-axis. The denominator in sign is always going to be positive because it's not a coordinate, rather it's a measurement. And when you're doing a measurement, it's based on a squared value, so it's always going to be positive. Something that has a measure has to exist, so it can't be negative. Remember, it's always going to be positive, okay? So the numerator of the basic trigonometric functions such as sine and cosine usually determine the sign, whether it's negative or positive, okay? So yeah, if you take a look at an angle that would fall in quadrant 2, let's say that this is our reference angle 18.95. Remember, the vertex is at the origin, the initial side is on the x-axis, and the terminal side is off somewhere in the quadrant. This is what your calculator is analyzing. It's not analyzing the actual value of theta. So in order to get the correct value of theta that also has the same sine value as this reference angle, what you would have to do is subtract the reference angle from 180, and that makes sense because when you get to quadrant 2 rather, the terminal boundary is going to be 180 degrees. But we're not all the way there. We have to take a step back. The step back is the magnitude of the reference angle. So it makes sense that you would subtract the reference angle to find out the actual value of theta. Okay? So that's what we're going to do to find out the possibility of angle B being not just an acute angle, but an obtuse angle, which is an angle that measures greater than 90 degrees. Hence, the measure of angle B is going to be 180 minus 18.95 degrees, which is based on this equation here, the quadrant 2 theta equation. And that's going to yield a value of 161.05 degrees, okay? All right. So there's still more steps that we have to endeavor, and we know the possibilities for the measure of angle B. Now we have to find out the possible measures for angle A, okay? So based on the assumption that angle B is, how do you say this, is not obtuse, it is acute. Sorry, I had a brain fart for a moment. The measure of angle A would be 180 because remember, the three angles of a triangle add up to 180 degrees. Then we're going to subtract our known given value in the question stem, 120 degrees. And then we're going to subtract one of our derived values for angle B, which is 18.95. And we find out that the measure of angle A in this scenario would be 41.05 degrees. Hence, we know that at least one triangle is possible, okay? So we can eliminate answer choice 3, that 0 triangles are possible. But in the event that angle B is its obtuse measure of 161.05, let's see what happens. So we get 180 minus 120 degrees minus 161.05 degrees. And the answer is negative 101.05. A second triangle is not a possibility. So remember that in the ambiguous case, you can only have 0, 1, or 2 triangles possible based on the given information of two sides and a non-included angle. Therefore, the correct answer choice is going to be answer choice 1. Okay? All right, thanks for tuning in, and inbox me at memedicine@gmail.com to order this complete Cram session. Bye.